You know, last week I was a participant of the AIME II 2023 maths competition, and when I first saw this question on the test, I was like, what? Well, I've never did any questions like these before, but eventually, somehow, I managed to get the correct answer. So let me show the question to you real quick. Here is the question. Consider the L-shaped region formed by 3 unit squares joined at their sides, as shown below. 2 points A and B are chosen independently and uniformly at random from inside the region. The probability that the midpoint of AB also lies inside this L-shaped region can be expressed as m over n, where m and n are relatively prime positive integers. Find m plus n. So first of all, if anyone is confused, here is the drawing that we're gonna use for the problem. It's like this. Okay, and then we're gonna label the 3 squares A, B, and C. Alright? We have 3 cases. The first case is that A and B are in the same square. So therefore A has a 1 in, so therefore A will have a 1. A can go to any of the squares, so it's a 1 in 1 chance for A. And B must go in the same square, so there's only one possible square of the 3 squares A will go in. So B has a 1 in 3 chance. Therefore the chance for this case is 1 over 3. And then for case 2, A and B are in adjacent squares. Right? So by adjacent squares, I mean like A and B or B and C. So for A slash B, A will have a 1 in 3 chance of being at the correct square, and B will have a 1 in 3 chance of having the correct square. So the possibility for that subcase is 1 over 3 times 1 over 3. And then you have to times 2 because A can be an A, or B can be an B, or A can be a B and B can be an A. It doesn't matter. So therefore the total for the subcase is 2 over 9. Okay, what about B and C? Same logic. A has a 1 in 3 chance of being at the correct square. B has a 1 in 3 chance of being at the correct square. And then the chance is 1 over 3 times 1 over 3 times 2. Because of like the ordering. So therefore the chance for the subcase is 2 over 9. Therefore the total for this case will be 2 over 9 plus 2 over 9 equaling 4 over 9. Okay, and then there's one last case. A and B are in squares A and C. So, which we're gonna find out later. Oh, and by the way, for cases 1 and cases 2, we don't have to do anything other than just finding the probability that A and B will be in those squares, because if A and B are in the same square, the midpoint of AB cannot go past the boundary of that square. And for case 2, if A and B are in adjacent squares, the boundary of A and B looks like this. So therefore the midpoint cannot go outside of this, of this thing or this thing, which also means it cannot go out of this thing. So therefore we just leave the 1 over 3 and the 4 over 9 as this. But for case 3, I'm just saying that A and B have to be in these 2 squares. And therefore there's a hidden line, there's some hidden lines in here. So therefore this is the boundary. And yes, it means that the midpoint of AB can go out of the Y. And what's the probability of that? That's what we have to find out so we can find out the answer. Here we got the total that we have previously, so you guys don't forget. And this is the case we are still doing. And as you can see, I've remade the diagram. So now we're gonna use some coordinate geometry. So we're gonna set this point as 0, 0. This point as x 0 because it's moving x to the right, and then it moves. And then these three squares are the same side length. So therefore, this will move another x to the right. So therefore, this is 2x dot comma 0. This one is moving x to the up, so therefore it's increasing the y coordinate by x also, because it's a square. And same for this one. This one is 0, 2x, and this is 0x. And yeah, so that's all we really have to know. Okay, so here's the formula. Here's the formula for you guys. The midpoint of 2 points. Wait, why is there no? Of 2 points, let's say x1, y1 and x2, y2 has the coordinates x1 plus x2 over 2, comma y1 plus y2 over 2. Sorry, that's my dog. Okay, so therefore we need to make sure that this point does not go to this. So therefore, let me just write that down real quick. This one cannot be larger than x comma x, because this coordinate is x and x, so it's saying that the x and y coordinates cannot exceed x at the same time. So you get two equations. Oh, actually, that's the wrong sign. Sorry. So if we multiply both sides by 2, we get x1 plus x2 equals 2x, and y1 plus y2 equals 2. Oh wait, actually it's this sign. Sorry. Okay, and by the way, x1 and x2 can be any value from x1 and x2 can be any value from 0 to 2x, and y1 and y2 can be any value from 0 to 2x. Okay, so therefore we have to use we're gonna introduce an idea of calculus so we can do this. Okay, so if x2 equal, so let's say x1, let's say x1 just starts in 0, and then x2 can range from the values of 0 all the way to 2x. Wait, we can actually illustrate this with a graph showing the values. So therefore this is x1 and therefore this is x2. So if x1 is 0, then this all the way to 2x represents the values x2 can be. This x1 is, let's say, 1/2 x, then x2 can be 0 to 1/1/2 x, 0.5 x, it's around here, and then if x1 is, and what if x1 is equal to x, x2 can just range from 0 to x, so then if you go to an x, x2 will look like this. Oh wait, I have to erase this. And if x1 is 1/2 of x, x2 is 0 to 1/2 x. And then eventually here is not possible. Okay, so basically as the x1 increases, the range of values that x2 can be decreases. So therefore, if we draw a more accurate chart, it will look something like this. And then it's gonna approach, and then it will approach triangle. It will coincidentally approach, the shape will approach a triangle with sides 2x and 2x. So therefore, the probability that the equation satisfies is the area of the triangle divided by the area of the square. Okay, so the formula of the area of a triangle is the height times the base divided by 2. So the area of the triangle is 2x times 2x divided by 2, which is 2x squared. And the square is 2x times 2x, which is 4x squared. So the ratio is 1/2. Therefore, the probability that this satisfies is 1/2. And if you use the exact same logic in the other equation, there's a 1/2 chance to satisfy. So therefore, for case 3, the probability that the two equations satisfy is 1/2 times 1/2. Oh, and don't forget the 2 over, and please include the 2 over 9 because the 2 over 9 is the remaining amount in here. In here, as you can see. Oh wait, but then we want the midpoint to be in the shape, not out of the shape. So we actually have to do, this is the complement. We actually do have to do 2 over 9 minus that. And that will equal 2 over 9 times, okay, minus, so these two can cancel out, and therefore this is a 1. 2 times 9 is 18, and therefore if you know anything about fractions, 2 over 9 turns to 4 over 18 minus 1 over 18, and that equals 3 over 18. So, and therefore, case 3 is 1 in 6. So now all you have to do is just add all the 3 values together. Let me erase the whole thing. Erase the clutter. Okay, we got some space. Okay, we got some space. So we can add this to our total. So again, all you have to do is just add these fractions together. Okay, so the common denominator of 3, 9, and 6 is 18. 3 times 6 is 18, 9 times 2 is 18, 6 times 3 is 18, so we can use that. This turns to 6 over 18, this will turn to 8 over 18, and this will turn to 3 over 18. And it's pretty easy, just do 6 plus 8 plus 3 divided by 18, and we get 6 plus 8 is 14, 14 plus 3 is 17 over 18. So therefore 17 over 18 is our answer. M equals 17, N equals 18, so the answer is 35. So this is the end of our, or should I say, my video about this problem. Well, the solution may look complicated, but please take some time to analyze and view my solution, and surely you'll understand. So of course, be sure to leave a like on the video, subscribe to my channel if you haven't, with the notification bell open. I don't know why I keep forgetting to say that. And please leave a comment down below if you have any tips or advice for me. So this is all for me today, so bye, see you sometime later. By the way, I have one last trivial question for all the math fanatics out there. Do you know which concept of simple calculus I used for my solution? If you know, then please let me know in the comments down below. Next video, I think I can give you the answer. Bye for real!